All right. Up next, we're switching things and we're going to start talking about solution stoichiometry for the next three problems or so. Again, pause, come back after you've tried the problem yourself. All right, so with solutions, one of the things I see a lot is people will confuse the fact that we have liters here also. So liters isn't specific to gases, it's a volume measurement. So we can also see it in solution problems. So here we want to calculate the volume of 0.1414 molar nitric acid. And immediately we should see molar or molarity and convert that into 1414 moles per liter, per 1 liter of HNO3, nitric acid. So I'm going to calculate the volume of that required to completely react with 12.1 liters of 0.116 molar, 0.116 moles per liter, magnesium hydroxide, MgOH2. Now, this is not a dilution problem, so we cannot use M1V1 equals M2V2. We know that because, we're calculating nitric acid from magnesium hydroxide. We have two different compounds that we're converting between with a mole ratio, because again, this is stoichiometry. So mole ratio always ends up in the middle. Now, we want to start with the thing that we can calculate moles of. And actually, this problem also gives us another hint because it says calculate the volume of nitric acid, which means that I'm going to be looking to calculate the moles of nitric acid in order to get that volume. And that means that the only other thing I'm given here is magnesium hydroxide. So I need to get to moles of magnesium hydroxide as part of my stoichiometry. Now, looking at the units that we have, if I rewrite over here, 12.1 liters of magnesium hydroxide solution and 0.116 moles per liter of magnesium hydroxide. I have liters and I have a conversion factor between moles and liters. So I can use molarity or the moles per liter to get from liters of magnesium hydroxide to moles of magnesium hydroxide. So 12.1 liters of magnesium hydroxide. Start setting this up. And then, do I divide or do I multiply? Well, look at my units. I have liters there. So when I take my molarity, my moles per liter, and I want to plug that in here, I know that I'm going to want liters on the bottom because I'm going to cancel that out because I'm looking to get moles. All right, now that gets me to moles. Now I need a mole ratio. So magnesium hydroxide, nitric acid, HNO3. It is 1 mole of MgOH2, magnesium hydroxide, 2 moles of HNO3, nitric acid. So that'll let me calculate moles. Now, we didn't actually finish our solution diagram here. So what's the last step? Moles of nitric acid. I'm trying to calculate the volume, which is liters. And my molarity, right? 0.1414 moles of nitric acid for every 1 liter. That's a conversion factor between moles and liters for nitric acid. I want liters this time, so I put liters on top. And 0.1414 moles HNO3 goes on the bottom. So whip out the calculator. 12.11, that's that first number there, whoops. Times 0.116 times 2 divided by 1414, enter. And that is 19.86, but we have 3 sig figs, so I'm going to round that to 3 sig figs, 19.9 liters of HNO3. And really, it's 19.9 liters of the 0.1414 molar HNO3 solution. So it's not just of the nitric acid, it's of that whole mix of solution at that concentration. So there's a last overview, and we'll move on to the next.